Welcome to Let's Do Revision official YouTube channel. So we continue answering Science Paper 1 of 2024 GCE. We are answering section B. So far we've answered from B1 to B6, and I hope you've watched that video already. If you've not done so, you can do so before you even come to this one. So today we'll continue from B7 going down. So the first question that we are answering is B7. Okay, and the question reads, figure B7.1 shows resistors connected to a 4-volt power supply. The first question is, what is the effective resistance of the circuit? What is the effective resistance of the circuit? Okay, so now for us to find the effective resistance, we are going to consider these two that are in parallel first. Then we add the one that is in series. So if you are given a question where you are given two resistors that are in parallel and one that is in series, you start by calculating the resistor for those that are in parallel, then you add the one that is in series. Now there's a formula that you need to know, the one that you use for calculating resistance when two resistors are in parallel. So this one works when two resistors are in parallel. So I'm going to say RT for total resistance. Then I'm using this one that requires only two resistors. So I'm going to say R. Let me just label these first. So I'll put this one R1. This is R2. This is R3. These R's that I've put represent resistance. So now, I mean resistance here. So now here, where they are in parallel, you have R2 multiplied by R3. Divide R2 plus R3. So this is the one that you can use for two resistors that are in parallel. So the number don't really matter here because I've just put these numbers. I'm not saying that every time you're going to find a resistors number that way. But you need to know that the resistors on top, you multiply them, those that are in parallel. Then at the bottom, you add them. Okay? So here to find total resistance, we are going to say 6 multiplied by 12, then divide 6 plus 12. What is 6 multiply 12? 6 multiply 12 is 72. Then divide 6 plus 12, which is 18. What is 72 divide 18? So we are able to find 4 ohms. So for resistance, total resistance for these that are in parallel is 4. But remember what I said, you add then that is in what? That is in series for you to find the effective resistance of the circuit. So effective resistance is equals to 2, or is it 3? This is the 3 ohms plus 4 ohms. So this one, if you add 3 plus 4, it gives us 7 ohms as effective resistance. Okay, let us look at the second question. Calculate the potential difference, PD, across the 3 ohms resistor. So PD is potential difference or voltage. How do you calculate potential difference? So we are told across 3 ohms resistor. So how do we do it? Now, before we even find the potential difference or the voltage here, because for you to find the voltage, we are going to apply resistor is equals to voltage divide current. So which means for us to find voltage, we need to multiply resistance multiplied by current. We have already resistance, which is 3, but what about the current? So we need to find the current first. Now for you to find the current, we are considering this one to be in a series connection. So current in series connection is just the same as the total current in the circuit. So for us to find the current right here, we are going to find the total current in the circuit. Okay, and for us to find the total current, we are going to divide total voltage divide total resistance. Okay, what is the total voltage that we have here? The total voltage is a 4 volts, which is given here. Then the total resistance that we found is 7 ohms. If you divide this, you are going to find that is 4 divide 7. 4 divide 7. You are going to find 0.57. 0.57 amps as the total current. But have we answered the question? No, we have not answered the question. The question wants potential difference on this part. So potential difference there, we are going to say resistance multiply current. What is our resistance? It is 3 multiplied by what is our current? 0.57. And this is going to give us, so multiply this one by 3. We are going to get 1.71. That is volts. So that is the voltage at 3. Okay. Let us proceed to the other question. So B8, figure B8.1 shows a cathode ray oscilloscope, CRO. As you can see the diagram right here. Name the process by which the cathode ray are produced. Name the process by which the cathode ray are produced. So this one is called thermionic emission. So thermionic emission is the process by which cathode rays are produced. Cathode rays are it's just a stream of electrons that is produced from the hot cathode there. Okay, and you need to know the heating process and all that. Okay, then now state the function of the Y plate in the Y plate. What is the function of the Y plate? Now the way they are here, look at this. Sometimes these might not be labeled, then they ask you to label these. So the parts you should know them. So these that are up, down, just know that these are Y plate. Sideways or sideways are X plate. Now the function of the Y plate, as the electrons are moving here, it diffracts them up and down. Okay, so we can say diffract the cathode ray vertically. Okay, up and down. So to diffract cathode rays vertically, okay, or up and down. Okay, then question C, why is the potential difference between the cathode ray and the anode very high? So the potential difference between the cathode here and between the cathode and the anode here is very high. What is the reason? So to accelerate the electrons, to accelerate the electrons. Okay, so that is the reason why it is more, the potential difference between the cathode and the anode are very high. Or to diffract, to accelerate the cathode ray. Okay, cathode ray, you know that the electrons. All right, let us go to B9. So B9, define nuclear fission. Define nuclear fission, and this is radioactivity. Okay, so this one was, the question is coming from basic electronics, so you need to know basic electronics, and this one now is coming from radioactivity. So define nuclear fission. So nuclear fission, just a splitting of radioactive nuclei. The splitting of radioactive nuclei. That is what we call nuclear fission. Then what is background radiation? Okay, that is B. What is background radiation? So background radiation is just a small amount of radiation available on Earth at all time. So small amount of radiation available on Earth at all time. Okay, small amount of radiation available, that is available on Earth at all time. Okay. Or you can say the radiation naturally in the environment. Radiation naturally in the environment. Then state two uses of nuclear energy. What are the uses of nuclear energy? So one, power generation. So nuclear energy can be used in nuclear power plant to generate electricity. Also making of bombs, nuclear weapons. Okay. Then also you can put for heating. So these are some of the uses. Then question D, complete the following nuclear equation. So the nuclear equation that we have is that we have 24, that is the mass number, atomic number 11, then magnesium plus beta. So long as beta is produced here, the general equation for beta is that the mass number remains the same, then atomic number increases by 1. So this one, to complete it, and gamma does not affect the mass number and the atomic number. So to complete this one is going to be, let me just rewrite it here, 12, then this is A, then now producing magnesium, so the mass number will still be 24, but this one will be 13. Is it 12? It will be 12, then plus beta plus gamma. So that is the complete equation. I guess you have no problem on this one. Okay, so the other question that came on the graph part, we are not going to do the graphing, but of course I'll just give you the question to try it out. So this one was on the velocity time graph, where you are given the numbers, then you plot the graph that is of velocity against time, then you answer the question that follows. I hope there's no one having problem on this part of mechanics. Then the other question that we can answer now is C2. So figure C2.1 shows a wave from form indicating voltage produced by a generator. Figure C2.1 shows a waveform indicating voltage produced by a generator. The first question is that what type of electricity is produced by the generator? What type of electricity is produced by the generator? So this one is called AC. Okay? So you can say alternating current, otherwise known as AC. Then determine the maximum voltage produced by the generator. So for you to look at the maximum voltage, you just look at the amplitude of these waves, or of these waves, yeah? So from here up to there, or from here up to there, that is the maximum voltage produced. So it is 5. Since it is in volts, so 5 volts. So for question C, state two ways in which the electromotive force EMF produced by the generator can be increased. So one way is by using a strong magnet. So use a stronger magnet. That is one way you can increase the electromotive force. Then the other one, increase the speed of the rotating coil. Okay. Then now question at D. Okay, so I'll clean this part since we've used the part for question D. Define a transformer. So a transformer is a device that step down or step up voltage. So in writing, you can say the device that varies the voltage. So the device that varies the voltage of the AC supply. That is a transformer. the device that varies the voltage of the AC supply. Then I'm going to remove this because the other question is draw a diagram of a step-up transformer. So how do you draw the diagram of a step-up transformer? Okay, so here, due to space, I'll leave this question to you to answer it. So how do you draw the step-up transformer? Then question E, explain why it is cheaper to transmit electric energy power or electrical power at higher voltage than at lower voltage. So, one, it reduces power loss through heating. It reduces power loss through heating. Okay. Then what does it mean to laminate the iron core of a transformer? That is question F. What does it mean to laminate the iron core of the transformer? So what it means is, it means coating iron core with an insulator. Okay, with an insulator. But of course, please, on this one, why it is cheaper to transmit electrical power at higher voltage than at lower voltage. So get to look at some more ways you can do that. Don't just limit yourself to the answer that you are given. It's not only one, but I'm sure there are other reasons that you can give. Okay, so get to find those reasons, and of course, make sure that you add them. Then question, that is C3. The first question is define nuclear fission, or define nuclear fusion, I mean. Define nuclear fusion. What is nuclear fusion? Okay, so I can say this is the fusion. This is the fusion of lighter nuclei. The fusion of lighter nuclei to form heavy nuclei, producing large amount of energy in the process. Okay, so nuclear fusion is simply the fusion of lighter nuclei to form the heavy nuclei, producing large amount of energy in the process. So that is how you can define it. So I'm going to remove this part to create room for, or space for, the question 2 on A. State two similarities between nuclear fission and nuclear fusion. What are two similarities? So this one, due to space, I'll just give it orally. So state two similarities. What are the two similarities between these? So one, both processes produce a huge amount of energy. So both processes produce huge or large amount of energy. I guess you've gotten that. Okay. In both the reactants are unstable radioactive nuclei. Okay, or reactant of both processes are unstable radioactive element. Reactants of both processes are unstable radioactive element or substances. Those are the two similarities. Let me just go through once more, or let me just give them once more. So one, we are saying in both, the reactants of both processes are unstable radioactive nuclei, and also both processes produces or release huge amount of energy or large amount of energy. Then for question 3, write an equation for the reaction of hydrogen and hydrogen to produce helium. So the reaction. So for this one is going to be 2, 1, then H, Okay, so hydrogen this and hydrogen that, plus hydrogen. Then what is going to form? It is going to form helium, like that. Okay, then of course plus 1 neutron with mass number 1 and the charge of 0, then energy. Okay, so that is how it is going to be. Then the other question, that is question B. Name device that can be used to measure nuclear radiation. So here I can put this one. Let me I don't know how we can pronounce this one. Molar counter or tube or counter. Then we have the spark counter as well. Okay, Geiger Muller counter, and of course the spark counter. Then we have question 2 of B. 2 of B. Which radioactive emission is not diffracted by electric energy or electric field? This is gamma. So gamma is not diffracted by both electric and magnetic field. So gamma rays. Then question C. A radioactive sample of mass 200 gram has a half-life of 8 days. How much of the sample would have decayed after 32 days? So we are looking for what would have decayed. Now, for you to find what would have decayed, you need to know what remained. Okay, so that is our target. We need to know what remained for us to know what would have decayed. And to know what remained, you use this formula. N just number of the sample that remained, or amount of sample that remained, that is N. Then N naught, the original or initial amount, then 1 over 2 to the power N, where N is number of half-lives and is calculated by dividing the time that elapsed or the period that passed, then divide half-life. That is the number of half-lives. For us to find this part, we need number of half-lives and we need the initial. From here, we are given a radioactive sample of mass. What? 200 gram. The initial amount was 200. Has a half-life. So half-life, we know it is 8 days. How much of the sample would have decayed after 32 days? So the period that passed was 32 days. So we can find N here, where we say 32 divide 8. And this gives us a 4. So a 4 is the one that we are going to replace there. So bring the 4 here. So you are going to have N over 200 equal to half to the power 4. Now half to the power 4 is just the same as let me say N to the power 200 is equals to 4 to the power 1 to the power 4 is 1. 2 to the power 4. What is 2 to the power 4? 2 to the power 4 is 2 multiplied by 2 multiplied by 2 multiplied by 2. This is 4, 8, 16. Okay? Then you cross multiply, you're going to have 16N is equals to 200. If we are to divide here, divide there, you're going to find, I guess you're going to find 12.5. So this is the sample that remained. Now we subtract from the original. So 200 minus 12.5. Okay? I guess this one should be able to give us 187.5. Okay? As the amount that decayed. Okay? Do we have an easy way of doing this? But if you have another way, please, that you can answer this question easily, make sure that you help out. Then the last question is, state one way of handling radioactive material safely. What is one way of handling this radioactive material safely? So one way is that do not use bare hands when handling these radioactive materials. So do not use bare hands when handling radioactive materials. Instead, use what we call tongs. Instead, use tongs. Then the other one, radioactive material should be stored in a container lined with lead. So they should be stored in a container lined with lead. Do not direct radioactive material to any human being. Wear protective clothing. Okay? Wear protective clothing every time you are working with radioactive material. Those are the safety measures that you can take. We have come to the end of the lesson. So please, if you've not subscribed to this YouTube channel, make sure to do so. Do not forget to turn on the notification bell that whenever we post the new materials, you'll be notified. And if you are interested to get the booklets for Let's Do Revision, make sure you get in touch. And of course, we are located in Kawata, near Kawata Primary School. Otherwise, we are going to meet in the next one.